Hi everyone. Alright, well this is our lesson today. We're going to work on completing the square a little more, and we also will try to lead to the quadratic formula a little bit. I'm sorry I'm missing you today. We'll look forward to seeing your outfits, but things are what they are. So first thing I want to do was kind of go over the steps for completing the square. You just need to get all this written down. We got a few examples. I'll do some of them. I'll leave some of them for you to do, and then you can just put all your work into Power School. But the steps for completing square, the first step I have is keep your x squared and x terms on one side of the equation, and your constant, the term that does not have a variable with it, on the other side of the equation. And then I started to write something else, and that's actually step 3, but I'm going to ask you to divide everything by the coefficient of x squared if it's something besides 1. The third thing is that coefficient of x. If you divide that by 2 and square that and add that to both sides of the equation, you'll complete the square. You'll have something that you can complete the square with. And then you rewrite the one side as a binomial squared, like x plus 3 squared or something like that. And then you finish by taking the square root of both sides. So that is, in a nutshell, how you complete the square. Well, let's do an example or two. And the first example I have is we're going to use completing the square, x squared plus 10x minus 13. And the first thing I asked you to do was to get the x squared and x term on one side. So I'm going to add 13 to both sides. And I have x squared plus 10x equals 13. The next thing I had you do was to complete the square. We need to take 10 divided by 2 and square that, and that is 5 squared. And so I'm going to add 25 to both sides. I have x squared plus 10x plus 25 equals 38. And then I'm going to rewrite this. This is equivalent to x plus 5 squared. Remember, we take 2 times the first term times the second term, we get that middle term. And that's equal to 38. And if I take the square root of both sides, I have a positive and a negative square root that we need to account for. I get x plus 5. So we're finishing by just taking the square root of both sides, equals the plus or minus square root of 38. And then if I subtract, and the square root cancel out. And then I subtract 5 from both sides, and I have x equals, I'm going to start with the negative 5, plus or minus the square root of 38. One solution is negative 5 plus the square root of 38. And the other solution is negative 5 minus the square root of 38. So there is example 1. And then example 2, I got one where we might have to divide, do that dividing step. But let's first of all add 5 to both sides. We got 3x squared minus 2x minus 5 equals 0. Now I've got 3x squared minus 2x equals 5. And let's just divide through everything by 5. And then we have x squared minus 2/3 x equals 5/3. Okay. So we are going to take 2/3 divided by 2 and square it. It's actually negative 2/3, but when we square it, it's going to be positive. I'm going to rewrite that just real quick. That's negative 2/3 times a half squared, which is, the 2's cancel, that's negative 1/3 squared. And when you square that, you get 1/9. So I'm going to add 1/9 to complete the square, I'm going to add 1/9 to both sides. Now 5/3 is 15/9. If I multiply 5/3 by 3/3, I get 15/9 plus 1/9, and that actually gives me 16/9. All right, and this is actually x minus, and it's this b value, b over 2 value, x minus 1/3 squared is going to give us that. And then if I take the square root of both sides, I got a positive and negative square root, remember, 16/9. The square and square root cancel, and that gives me x minus 1/3 equals plus or minus, and square root of 16/9, I'm trying to find a good place, is the square root of 16 over the square root of 9. We can divide that up, and those are both perfect squares, so that's plus or minus 4/3. And I'm going to add 1/3 to both sides. And this is x. Now we don't have a radical this time. 1/3 plus or minus 4/3. So I'm going to go further and actually take 1/3 plus 4/3 and get 5/3. And I'm going to take 1/3 minus 4/3 and actually get, that's negative 3/3 or negative 1. So x equals 5/3 or negative 1. My solution's there. Okay. That's example 2. Now, I want you to take a moment, and you can pause, but I want you to do example 3 here. Solve by completing the square. And then I want you to do example 4. Again, solve by completing the square. And now you can pause it and get those done. When you are done, come back to the video. And now we have example 5. Now, I just have a very general formula, ax squared plus bx plus c. That is a general quadratic expression. We've got set equal to 0. We're going to solve this by completing the square and see what happens. Well, if you remember our steps, I said let's get the constant. It doesn't have the x. A, b, and c are just numbers. So I've got ax squared plus bx equals negative c. And in my second step, I said divide by the coefficient of x squared. So let's divide everything by a. And that gives me x squared plus b over a x equals negative c over a. Okay, this is, again, it's going to be very general. We don't have specific numbers here right now. So I need to take the coefficient of x and I need to divide that by 2, and I need to square that. So when I take this, let me take b over a, instead of dividing by 2, since I have a fraction, let's multiply by half. And then I've got b over 2a, and I'm going to square that. And when I square that, I think that gives me b squared, and 2 squared is 4, and a squared is a squared. So b squared over 4a squared. B squared, and then you got the 2 squared, and then you got the a squared. So that's what I'm going to add to both sides. Let me do it where I have a little bit more room. X squared plus b over ax plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. And I want to get this into one fraction. So if I take the negative c over a and multiply it, okay, notice that I would need the 4, and I would need another a to get 4a squared. So I'm just trying to get a common denominator. It looks like 4a squared would be it, and then I got the b squared over 4a squared. And that's negative c times 4a, which we usually write alphabetically, negative 4ac plus b squared over my common denominator of 4a squared. And let me just rewrite that as b squared minus 4ac over 4a squared. So this part, now I took a couple steps and showed just how to get this into one single term. Instead of the sum of two expressions, one single expression here. I'm going to now, I'll just come down here and do this part, write the binomial, and if you'll remember, it was b over 2a, x plus b over 2a squared. And then it's time to take the square root of both sides. So I'll take the square root of this side, I'll take the square root of this side, the square root and square cancel, so that's x plus b over 2a equals, I'm going to separate these two because this looks like a perfect square to me. I'm going to take the square root of b squared minus 4ac over the square root of 4a squared. Oh, I mustn't forget, we've got a positive and a negative, and I'll just leave it up there on the numerator, positive and negative, and the 4a squared. Well, now I've got x plus b over 2a equals plus or minus the square root of b squared minus 4ac over, and the square root of 4a squared, square root of 4 times the square root of a squared, square root of 4 is 2, square root of a squared is a, and let me just get another piece of paper to keep going here. I'm going to subtract b over 2a from both sides to get x by itself. And I'll subtract b over 2a from this side. And when I write that, I'm going to write negative b over 2a plus or minus square root of b squared minus 4ac over 2a. And those happen to be like terms. Or common denominator is what I meant to say. And so that gives me negative b plus or minus the square root of b squared minus 4. I lost the c there, didn't I? Bring that c down. Negative b plus or minus square root of b squared minus 4ac. And my denominator over the whole thing is 2a. And what we have here is the solution to ax squared plus bx plus c equals 0. And that happens to be what we call the quadratic formula, which you need to know. And maybe I'll help you here a little bit, because I have a snappy tune to go with that. And it goes like this. It's the Notre Dame fight song, by the way, if you don't know this. But x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. X equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a, and there you go.